Hey everyone, it's Mrs. Wallace. I just wanted to do this one worksheet quickly because I think a lot of people had questions about it, especially this first question and this second question, which relate to the types of game theory questions that you're likely to see on the AP exam. This looks a little bit different than what we did in class, only because the payoff matrix might have had some cells that were separated by commas. In this case, we just have the lines, but it's always going to be the same type of setup. We have a player on the left and a player on the top, and all of the payoffs that are to the left, would relate to the player on the left, and all of the payoffs that are on the, kind of right-hand side of that slash line, those would be for the player on the top. And in this first question, we have two payoff matrices. Both of these would be, kind of questionable. Are they prisoner's dilemma? That's one of the things that we have to check out. So I'm going to go and kind of see if these players have dominant strategies or if I can figure out the Nash equilibrium, okay? So if I am going to play the first game and I'm going to look from the perspective of GM, I'm going to imagine that if Chrysler doesn't invest, so I'm looking down the column of only not investing if it's Chrysler, and for GM, if Chrysler doesn't invest, GM could either invest or not invest. Investing gives a higher payoff, so let's assume that GM invests. If we look at the second column, that if Chrysler invests, so everything in that second column in the payoff matrix, now I would see that GM should invest because investing for $5,000 is greater than $4,000, which would be not invest. So regardless of what Chrysler does, GM should definitely invest. So they do have a dominant strategy. GM should always invest. If I look at the situation, if I am Chrysler, if I imagine that I'm looking at the top row now, if GM does not invest, what should Chrysler do? Should they not invest for $10,000 or should they invest for $12,000? They should invest for $12,000. And if GM does invest, Chrysler could choose between not investing for $4,000 or investing for $5,000, which is what they should choose. And you might notice that if you do put little arrows next to each player's best response, depending on what the other player is doing, you might have a cell where both players are playing their best response. That's going to be the Nash equilibrium. So in this case, the Nash equilibrium is invest, and that's going to be the answer to that question. What does a Nash equilibrium mean? Okay, both players are playing the best response relative to what the other guy is doing. Okay, so regardless of what the other guy is doing, right, the other guy is doing left, whatever our best response is to that. If the other guy is doing right, whatever our best response is to that. If both players are playing their best response to the move that the other player is making, you're at a Nash equilibrium, okay? How might the strategy change for each player in the prisoner's dilemma above if the game was played consecutive times, okay? Well, if we wanted to ask if this is a prisoner's dilemma, the answer is, yes, that it is, okay? Why? Both players have a dominant strategy, okay? So one thing we know is both players have a dominant strategy. Both players play their dominant strategy, in this case, invest. When they invest and they're at a Nash equilibrium, each getting a payoff of $5,000, they are not at the most optimal cell in the payoff matrix. If they could collude and get together and Chrysler and GM met on the golf course, the better payoff would be if they both don't invest. But it's not a stable cell, even though it might be socially optimal, and if they could choose it, they might decide to create a contract and agree not to invest. If both parties didn't invest and they were able to do that, the problem is there's a likelihood to cheat. Chrysler, which is not investing, has an incentive to invest, right, for an additional $2,000, and to backstab Chrysler, which when they're not investing and GM invests, GM wins out. And the same thing with the other player, Chrysler at $5,000, has an incentive to Chrysler at the 10,000 has an incentive to move to 12,000. So it is not a Nash equilibrium. It's not stable. Don't invest is the best option. They might collude there, but it's not stable. There's likelihood that we will see cheating. So, the answer is this a prisoner's dilemma? And yes, it is. In terms of the second one, okay, if we look at GM should should invest if Chrysler doesn't invest, and GM should also invest. So there is a dominant strategy for GM. With Chrysler, in this case, if GM doesn't invest, Chrysler should not invest, and if GM does invest, Chrysler should not invest, okay? In this case, all right, we're ending up with a Nash equilibrium. This is the Nash equilibrium, okay? And we have each player has a dominant strategy, right? Either not invest or invest. But this is not a Nash equilibrium. This one is not a Nash equilibrium because the Nash equilibrium is not. It is actually Pareto optimal. It is not the worst case scenario whatsoever. If they colluded, they would choose this, right? This is not a dilemma at all. Okay, this is where the Nash equilibrium has benefited both players. Okay, all right, I'm going to stop there for a second, and then we'll move on to the second question. Okay, the second question, a little bit more straightforward, right? We have two players, Discounters Deluxe and also Quality Brand. And this is about whether or not the two players should reduce or not reduce, okay? So if they're going to reduce or not reduce. If I look at what happens if Quality Brands reduces, Discounters Deluxe should reduce, okay, because 5 million is greater than 1 million. If Quality Brands does not reduce, then Discounters Deluxe should reduce. So is there a dominant strategy for Discounts Deluxe? Yes, they should reduce, okay? The question becomes, is there a dominant strategy for Quality Brands? Well, if Discount Deluxe reduces, Quality Brands should reduce. But if Quality Brands does not reduce, then, if Discount Deluxe does not reduce, then Quality Brands should not reduce because 3.5 is greater than 3 million, okay? So in this case, there is no dominant strategy for the Quality Brands because on one occasion when Discounters Deluxe is reducing, they should reduce. If Discounters Deluxe does not reduce, then they should not reduce, okay? So even though they have a best response to what Discounters Deluxe is doing, it's not always the same best response, and that's what a dominant strategy would be. Where is the Nash equilibrium? Well, I can look for the cell that has two lines, right, where both payoffs were the best response. Simultaneously, each player is picking the same cell as a, kind of best response. In this case, reduce would be the Nash equilibrium. Is this a prisoner's dilemma? Okay, it is not. Both players do not have a dominant strategy. They're not playing that dominant strategy in order to get the Nash, and we don't have a situation where the Nash equilibrium is necessarily the not the socially optimal one on the board. It's really hard to tell exactly what these two players would collude to, what would be most optimal. Okay, it's different for each player. Okay, I hope that helps, and I will see you tomorrow. If you have questions on the quiz, just ask.